So welcome back to lesson 2 of week 6, and last lesson we looked at the NOT gate. Now we'll look at some other logic gates. In this lesson we'll look at 3 Boolean operators, AND, OR and XOR. We've talked about all of those before. We'll look at the logic gate symbols that go with those 3 operators, the truth tables and the Boolean symbols. The operations are sometimes described as conjunction and disjunction. AND is conjunction, OR and XOR are different types of disjunction. The AND gate is a circuit with 2 inputs and 1 output. And the gate outputs an electrical charge if both of the inputs to the gate are switched on. So it's a bit like the way the word AND operates in everyday life. If both of the things you say are true, then you can say that the first one is true and the second one is true. And the truth table works the same way. So if A and B are true, if they're both true, then the output is true, but otherwise the output is false. So imagine I said, I'm going to watch telly and do my homework. If only one of those was true, the overall expression is not true. If I just watched telly and didn't do my homework, then my expression was not true. It's only true if I do both of those things. And the way we write this in Boolean algebra is like this. That symbol there represents AND, so this expression says Q is equivalent to A and B. That would mean Q is only true if A is true and B is true. We can imagine how this might be used in everyday life. For example, to log on to a lot of different social network systems, you have to give a username and a password. So an AND check will make sure that both of those have been correctly entered before you're able to log in. And there would be the truth table that goes with that. If the username has been entered and the password has been entered, then you log on. The first 3 options are false and only the 4th option produces a true output. OR and XOR are used the way that OR is used in everyday speech, and we use OR in 2 different ways in our colloquial speech. Sometimes we mean that either might be true or both might be true, or sometimes we mean that only one is true. So for example, I might say I'm going to watch telly or do my homework, and that you would usually say that was true if you did either of them, and if you happen to do both, that would be true as well. You haven't told a fib. However, sometimes I use OR to mean that only one of the 2 things can be true. For example, you must do your homework or you will fail the test. And here I'm implying that one or the other of those 2 things will be true, but they can't both be true. So we use OR for the first of those and XOR for the second. Don't worry, I'm going to show you some examples now. So here is the logic gate for OR. You can see that compared to an AND gate, it's got a pointed front and a curved back. So they are quite similar to each other, but it's important that you draw them carefully to show the difference. And the truth table for an ordinary OR gate looks like this. So the output is true as long as at least one of the inputs is true. And the Boolean symbol looks like this. It looks a bit like a V. It's the opposite of the AND symbol. XOR, on the other hand, looks very much like OR, but it's got an extra line at the back. So this is the symbol for XOR. This is the final gate symbol that you need to learn. And the truth table looks like this. So the output is on if the two inputs are different. But if the two inputs are the same, then the output is off. We'll do less work with Boolean symbols of Xor, but if it does come up, they look like this. There's two possible ways of showing the symbols, as an underlined or symbol, or sometimes as this circle with a cross in it. I just want to stop and say that if you've done electronics, the electronics symbols for these gates are different than the Boolean symbols. Just because they have different traditions and they've grown up amongst different communities. So in the computer science exam, we'll be using these symbols that I've just shown you. So let's summarize what we've learned. We've learned 4 different Boolean operations, not, and, or, and Xor, called negation, conjunction, disjunction, and Xor is sometimes called exclusive disjunction. And there are the 4 Boolean symbols. And here are the 4 gates. Make sure you know which gate goes with which operation. If you can't remember, look back at the work that we've just done. There are some other gates that are sometimes used when we're drawing logic circuits, and these are the NAND and the NOR gates, and you can see that they look like the and OR gates, but they've got a little circle after them. These are not in the syllabus. They're like fitting an AND gate and a NOT gate together. It has the same effect. You might see them in examples of circuits online, but they won't come up in the exam. So in this lesson, you have looked at the logic gates for the 3 operations AND, OR, and XOR. You've looked at the truth tables for those operations, and you've looked at the symbols for those operations. So go to your notebook, your revision book, and make notes so that you've got notes on AND, OR, and XOR, covering the logic gate, the truth table, and the Boolean algebra symbols for all 3. Okay, so in the next lesson, we'll look at fitting the gates together to make circuits. So I'll see you then. Bye for now.